students, I'm going to go over examples from here for your circles day 6, an arc measure and arc length. You're going to get some others on arc length. This also has a lot to do with circumference, which is part of arc length, but circumference is the entire distance around, whereas arc length is only a fraction of the distance around. So you'll get another worksheet with more examples with arc length. That's always on the DCAS, commonly missed one, because the kids don't memorize the formula, which you have on your DCAS sheet. All right, angle HOJ, right there, 75 degrees. We call that a central angle. We know the central angle equals its arc measure. Okay, don't forget we got vertical angles are congruent, and therefore we have a linear pair here, so that makes these 105. Okay, now find the arc measures. FH, we know the central angle equals its arc measure, so it's 105. GJ, 105. FG, 75. Very simple. Find each arc measure. Now, so that was with numbers. Now we have some algebraic expressions doing the same idea. Well, what I can see right here, I can move this 3x across to right there if I wanted to. If I want to talk about this diameter right here, okay? Or I can just look at it as this is a diameter right there, and then I have this semicircle. Okay, so all those add up to 180 degrees. So I have 6x, 8x, and that's minus 12 equals 180. I mean, not minus 12, plus 12. 15 minus 30 is 12. Okay, so I have 8x equals 168 divided by 8, and I get 21. So x is 21. Fill it in. I'm not going to do that. You can do that. All right, exact circumference. You need to know circumference formula. C equals pi d or 2 pi r. You need both those memorized. D equals 2r. That's why you can see it there. The pi is the same. That means D has to equal 2r. That's what the diameter equals, 2 times radius. So again, here I can look at this. I have a right triangle, and I can see it. I divide each by 2, and I have an 8, 15, 17 Pythagorean triple, which makes this whole length 34, doubling it back up. So the diameter is 34. So I'd have C equals 34 pi, and then whatever the units are, meters. Don't forget units. All right, angle AGB is 30 degrees. Well, that would make that 60 degrees since that's 90. Okay, and I have vertical angles there. Okay, and I have this vertical angle here, so that's 150, so that makes this 150. Right there, now you can fill in their arc measures. It's like above, number 1. Exact circumference again. I have a 3, 4, 5 Pythagorean triple, so it's going to be 5 pi feet for my circumference. Here I have a isosceles right triangle you should recognize it as, which means it's a 45, 45, 90. If the sides are 10, we know on a 45, 45, 90, the hypotenuse is always root 2 times longer. So pi d, so I'm going to have 10 pi root 2 inches for my circumference. Exact. Notice this is exact. Exact means you must leave pi in the answer. You cannot put pi in the calculator and get any decimals. Everything is exact. You can't put square root of 2 in the calculator. It gives you a decimal. That's not exact. That has to stay exact. All right. Here, this is just testing some of your vocab at the front and stuff we've already done above. Okay. Exact circumference again. Again, I see I'm an isosceles right triangle, so I multiply the hypotenuse by square root of 2, multiply the side by the square root of 2 to get the hypotenuse. XZ is 8, so that's the radius. Angle ZXY is 45. Find the exact arc length of YZ. So this is one that you could easily see on the DCAS. So we have to know our formula. It's a fraction, so it's x over 360 because there's 360 degrees in a circle. X, we happen to know what x is 45. I'm just writing down the formula first. Okay, and then I'll fill in the 45 in just a second. So it's a fraction of the circle And we're talking about the arc length. So what's the arc length formula? Or circumference, same thing. 2 pi r. We just got done doing it above. And now I know what that x is. It's 45 degrees right there. So 45 divided by 360, that reduces to 1/8. There's 8 45s. You can put that in a calculator. Okay. And then times 2 pi r. Well, now the 2 cancels the 8 4 times. What's the r? The r is 8, so I can now substitute 8 in for the r. And now 8 cancels that 4 2 times, so I'm left with 2 pi. And then if there's units, whatever the units happen to be, that would be my arc length. But that's that formula you have to have memorized. It's not given to you on the DCAS. So when you're doing your DCAS, quizzing each other the first 10 minutes of class, make sure you're asking that question to each other. Okay. Let's see, find the radius. So this is going backwards. So you could have it either this way is 6, or they go backwards. They give you the arc length, and they want you to find the radius. So it's the same formula. Equals the arc length. Okay, well in this case we know the arc length, 14.2. We don't know the radius, but we know the degrees, 132 out of 360, 2 pi r. So we're now solving for r. And this would be to the nearest 10th. We're going to go because they've gone to the nearest 10th in their problem. Okay, so I could type in on my calculator. Let's go ahead and bring up the calculator. So you see a graphing calculator. Hopefully it comes up here soon. Start, move it down, come on, move down, start. Calculator, clear, okay. So let's look at what we have here. I can multiply 132 times 2, it's 264 times pi. 264 times pi divided by 360. 264 times pi divided by 360. That gives me everything on the left side. Okay. Now, on the right, I have 14.2. So I'm 14.2 divided by that answer. So 14.2 divided by answer, second negative sign, gives me answer. That means the answer above, 2.3, etc. And that gives me 6.16. We're going to round to the nearest 10th, as we said. So 6.2 is the radius. So radius is approximately 6.2, whatever the inches are, inches. Units are inches. Don't forget units. Okay. Here again is going backwards. Find the exact diameter. Make sure you find the diameter, not just the radius. When the circumference is 65 feet. Well, since I want diameter, I'm going to use the pi d formula. So I want diameter, and I just divide by pi on both sides. Now it says exact, so that means I have to leave it, and I just add on the units. So 65 divided by pi feet is my answer then for, therefore. Okay, exact radius on the circumference. So circumference equals 2 pi r. So I'm solving for radius. I'm going to use the 2 pi r formula. So I'm going to divide by 2 pi on both sides. So 51, you can leave it as 51 over 2 pi, whatever the units are, units, inches. Or if you want to do 51 divided by 2, you get 25.5 divided by pi inches. Those are the same thing. Okay. And one last one we'll go through on the back side here. This is also on the back side of your sheet. The first like 6 or 8 problems are like this. So I'm just doing one of them. All right, find the length of the darkened sector. So this is the dark, change the color so you can see it. The red is the darkened sector you can see. So if that's 45 degrees, what's 360 minus 45? That's 315. Okay, so we have 315 over 360 times 2 pi r. Remember, that's the circumference we're trying to find. Now notice it also says leave your answer in terms of pi. It's another way of saying the exact answer. Pi has to be left in the answer. Okay, and I know what r is, 20. So I can substitute that 20 into there. Okay, so there are 8 45s and 360, and we're subtracting off one of them. So that's 7/8 is what that reduced. So you can put in the calculator, hit math, enter, it'll give you 7/8 times 2 times pi times 20. Well, that 2 will cancel the 8 4 times. Well, now that 4 will cancel the 25 times. And so I have 35 pi. And then whatever the units are, meters. Okay, exact answer. Okay, you should be able to work with fractions. If you plan on going to higher math, you better be able to cross-cancel your fractions like that, or you're going to struggle when you get to pre-calculus and calculus when it deals with fractions like this and having to do that. You're not going to always have a calculator. Okay, for the rest of you, you could just plug all that in a calculator, give you 35. Okay, that will do it. 11.5 minutes.